All right, thank you. Can everybody hear me? This thing's on and working? Good. What I wanted to do today was talk a little bit about a dinosaur that is important for Utah in that it is the first, historically the first dinosaur that was ever found here. If we take a look at the Morrison Formation, everybody's pretty familiar with this likely. This is a representation of what you might have seen at Mill Canyon around Moab, or Dinosaur National Monument, for example. This is about 150 million years ago. You've got things like chimerosaurs and brachiosaurs and diplodocids of various types. There's a pretty good diversity of sauropod dinosaurs in the Morrison Formation from a little bit late in the late Jurassic epoch. But what we want to talk about today is a find that's geologically older than that, and which predates most of the finds in the Morrison Formation. So the initial discovery related to an Army expedition that was led by John McComb. They started out in July of 1859, and he was charged with basically following the old Spanish Trail route into Utah from Santa Fe, New Mexico, and he was supposed to do a couple of different things. One was to locate the confluence of the Green and the Colorado rivers, at that time the Grand River. They didn't really know exactly where it was. Maps prior to that actually showed basically a guess of where that confluence was. In some cases, they had the island and the Sky District of Canyonlands figured out, and they knew the rivers came together just below Grandview Point, or what is now Grandview Point, but the location of it was almost down in the Grand Canyon. So things were a little bit off in these early maps. So they were trying to find out more exactly where that was, and the other thing they were trying to do was figure out a reasonable military route into Utah if they needed that. So here is basically a period map of the area that they were working in. Notice region unexplored scientifically for basically Arizona and New Mexico down here. And where they were concentrating on was trying to find that confluence, which you can see here is a little bit, as you move your way down from the Grand and the Gunnison and get down in this area, things kind of straighten out. They're getting a little bit more general with their idea of where it is. Now, McComb was basically taking this route in from Santa Fe along the old Spanish Trail. They got out to an area where they could just barely see it, and they headed back. They were gone for several months. This is just to orient you on where modern towns are relative to things. So today this is approximately an hour south of Moab, and then where they ended up finding this thing was down just a few days before they ended up turning around on the return trip. Now the good thing for McComb, as it turns out, was that he had this guy, John Newberry, with him as a naturalist. He was actually trained as a physician, and later on he ended up serving in the Union Army for the Civil War as a surgeon and doctor. Here he is about the time that he did this expedition. He was about 37 at the time. Another guy that McComb had as well was Charles Dimmock here, who was his topographic surveyor. Now, both these guys kept journals, and the good thing is that Dimmock actually was keeping track of where all their camps were and what headings they were on, and how many miles exactly they were between sites. This turned out to be important later on. Now, I mentioned their journals. On August 17th, near what they called Camp 26, which is near modern-day Monticello, they made some notes here. Dimmock actually usually put a little bit more information in his notes, although they were obviously guessing at what this animal was. But they both note that these bones had been found near there in 1859. The interesting thing here, August 17th, 1859, that is 50 years to the day before Earl Douglas found Dinosaur National Monument, or what became the Coriat Dinosaur National Monument. The other thing I find kind of interesting about this is that in his journal, Newberry talks about himself in the third person. So this is some of the material that's now at the Smithsonian that they packed out on mules. McComb had about 60 people with him, and they were all on mules. And some of the material they found, a scapula fragment here, a nearly complete ulna, and then a few metacarpals, bones from the hand, basically. Now, Newberry was disappointed in that they had neither the time on this military expedition nor the tools to be able to get the thing out. And so he actually said something rather prophetic, that the skeleton remained for a future geologist with more time and better tools to excavate than they had on their muleback expedition. So the site, when they got back to Washington, D.C. from San Jose after the whole trip was over, shortly after that, less than a year, the Civil War broke out. McComb, Newberry were involved on one side, DeVinck on the other, and the whole thing was forgotten. The report on the McComb expedition didn't actually come out until 1876. So in all those years of distraction, nobody really knew where the site was anymore. And decades later, even fewer people knew. And so by the 1970s, nobody knew at all where this site was. But luckily, Jack McIntosh, a sauropod expert, was aware of a number of the papers that had come out about this. It was kind of an obscure dinosaur for a long time, but he at least knew what was known of it. Now, he was interested in trying to find out where this thing had come from and try to see if there was any more of it. So he asked Jim Jensen from BYU, who had been working in the area for some time, if he thought he'd ever excavated the site, possibly without knowing it. Jensen was pretty sure he hadn't, but he told McIntosh they thought he might know who would. And so Jensen actually contacted this guy, Fran Barnes from Moab, who has been over basically every square inch of land out in the Moab area and knew the area very well, kind of an amateur naturalist himself. And Jensen actually talked Barnes into going out and trying to find this site. And so Fran Barnes spent 12 years researching the journals of the expedition and reading or looking at the maps that Dimmock had done with all his recordings of the camps and how far they were. He basically narrowed the whole thing down and ended up relocating the site through, once he'd narrowed it down, he did nothing more than hiking around, essentially prospecting until he found a site in that area that matched the description and had a bunch of bone in it. He got a hold of Dave Gillette, who was the state paleontologist at the time and had only actually been there a couple of years. Dave took a look at the evidence. They went out and visited the site. Fran managed to convince Dave that it was the original McComb site from 1859. And then in September of '89, they went out there for about 10 days and spent some time at the site doing some excavation. And they mainly, as you can tell here in some of these shots, they mainly swept down the surface of the site. They saw how much bone was in place. They picked up a lot of material off the surface, and they actually collected a fair amount of material that's here at the museum in the collections room, as a matter of fact. And some of it, well, most of it isn't very identifiable, but there is a lot of it, and there are a few rather key things in that collection, as it turns out. This is what the site looked like about 9 years later. By 1998, this is when Dave Gillette was going back up there with Fred Peterson from the USGS. I went up there with him because I was just starting to work for Dave down at the Grand Staircase. And at this point, Dave was wanting to get back up here to re-excavate the site for real, but he'd had some recent knee surgery, and shortly after this, he lost his main field guy who was responsible for the logistics of getting up here and getting all the material out. And so Dave never really got around to working at the site. And so by 2014, we went back, we got a grant from the Canyonlands Natural History Association, and went back out to the site. This was me and Randy Ermis with the museum here and his crews. We made a point of going back in August of 2014, 155 years to the day since the Newberry excavation, so we could be out there at the same time. We called this camp Mosquito Flats because in August, after all the rain we'd had, it was awful. And our main goal was to basically excavate the quarry, going a little bit deeper than Dave and Fran Barnes had, try to get more of the skeleton, and trying to find out what this thing is related to. It's in a rather key position stratigraphically. The main problem, of course, is that it was right on top of this 250-foot cliff of Entrada sandstone, which goes all around the canyon there. This was the thing that Dave and his field guy had been struggling with for some time, was how to get everything up and down there. And so in 2014, this was pretty much our daily routine. We didn't have to go straight up that 250-foot cliff. We managed to find an area where we could go up a couple of shorter pitches and then hike the rest of it. But we went up the ropes every morning and came down each night. And when we started, this is basically what it looked like. It was covered in a bit of sand, loose sand debris. Here's Ella actually just beginning to shovel in and get down to the main bone layer. It had filled in a little bit even since the since the 9 years earlier that Dave and Fran had been out there. Another thing we were dealing with here, here's Kelly Trujillo working out there with a nice sandstone block. There were two over the quarry that were a little bit dangerous. And so one of the things that we did in 2015 was to get rid of that. Here Tyler is actually using a car jack to wedge that thing out, and we just rolled them down the hill to get them out of the way. Then we took pry bars in, started taking the overburden off and get a nice flat spot to work on. And by the time we were done, we had a pretty good bench going there. We've since expanded it kind of towards the camera here relative to this view. So we've been able to get going. Oh, I'm hitting the wrong thing. So anyway, we got going. You can see here, Carrie's working on the surface here. We've capped a few of the bones. Just a little bit of what the bone looks like here. Edge of a limb bone just being exposed. Small section of probably a rib or something of that sort. A distal tail vertebra, one of the first vertebrae that came out of that site, found by Keegan back in 2014. He actually found 3 of these right next to each other. A little bit of wood, some plant material that's mixed in with the quarry as well. We also found 1 bivalve. Some of the jackets were a little bit smaller. This is capping the bottom sides of a couple of small ones that Yella's doing there. You can also see working on a larger jacket here and our main datum line for doing the mapping. It was an interesting site to work in that unlike a lot of sites where you normally will expose a bone completely and then trench around it, isolate it, and take it out, we've not really ever been able to do that here. What we've mainly had to do is use natural cracks. And so, for example, we'll use a pry bar or something of that sort to expand a natural crack in the rock, and then we jacket each of those blocks, and each of these come out, and we prep them in lab. And so mostly we don't even see what we're getting when we're out in the field. The surprises are really left for the lab. Now in 2014, getting out of there was time consuming. We probably spent about 60% of our time at the site involved with the logistics. And so, for example, as we carried things out, we had them strapped to a backboard here, and we just had to lower them down. And then on the upper part, we actually tied it to a furniture dolly and lowered it slowly so that we basically just had to drop it like that, slowly inch it down, hope that the whole thing didn't break loose and go down and smash. We got very tired of this. We spent an entire morning wrestling a single jacket down once with the entire crew. So we decided next time we go back, we're doing it the easy way. And so we actually talk National Geographic into paying to get a helicopter to take all our gear up at the beginning of the week and fly everything back down at the end. And so here we're putting everything in cargo nets, and then it just came in and flew everything from the flats up here up onto the top of the cliff and saved us a lot of back-breaking work. So we had a pretty productive year in 2016 since we were able to just go up the ropes and start working. And this is what we've gotten out so far. I made a note when I was down there that I wanted to see where one of our jackets was here. Actually, one of these you can see down in the lab right now being prepped out. But that's what has come out so far that we've mapped. And 2016, it was a long day wrapping up the day that we finished. We ended up putting all of our gear that was going back down, plus the 16 field jackets that we'd gotten, back in the 3 cargo nets. Got out there pretty late that day, and then the next morning the helicopter was able to come in and lift everything out. So it was infinitely easier than it had been the first 2 years. So I mentioned the importance of this particular site. Dinosaur National Monument, for example, well known for lots of sauropod dinosaurs, Cleveland Lloyd, Mygat-Moore, various other big quarries that are regional, all up at those levels in the brushy basin member, dry mesa around there. Dystrophies is down the Tidwell member, so it's quite a bit lower stratigraphically than most of the other ones. The first evidence of sauropods in North America is down here in the Entrada with a trackway, and so Dystrophius is actually the first skeletal evidence of sauropods showing up in the area. So it's important to see what this animal is and who it's related to see how it compares to sauropods a little bit further down. We checked the age with a sample that we sent to the University of Wyoming. These little guys are zircon crystals. These ones are separated out as ones potentially that formed during Morrison times in volcanic ash debris that flew out onto the floodplain and got mixed into the mud. These are a little bit rounded. Zircons are notoriously tough, and so they tend to get recycled a lot. And so a lot of these zircons are probably as much as 1 billion years old. So what we're looking for are the younger ones that may have fallen with the ash during Morrison times. Now, when we ran that particular result, it came out at about 158 million years. The important part of that is that it's significantly older than the material. Significantly older than the good sauropod material from higher up in the formation. Another thing we did was take a look at the old Newberry material. Here we have the ulna, which Randy had a CT scan when he was back in DC last year, I believe it was. The neat thing about this was able to put this slice back together and kind of indicate where cracks had been repaired and show up a little bit better where the bone was not original. This is some of the material I mentioned from 1989, some additional foot bones and things like that. There was a tooth in there that we did some micro CT on so that we could get a little bit better idea what it looked like without having to prep it out. This is some of the material that we collected back in 2014. There are now about 25 main jackets of it since we got 16 more out last year. It's undergoing prep. You can see one of the jackets down there, as I mentioned, in the lab. These are a few of the things from 2014 that we took care of as far as the prep goes. Now, what it is, we've got various things like Apatosaurus, Brontosaurus, Diplodocus, Camarasaurus, Brachiosaurus, relatively common higher up in the Morrison Formation. Again, number of sauropods, most of them seem to come from this middle brushy basin area. Dystrophius, again, a bit lower than that. These guys, this is basically just what this thing has been identified as. Previously, it's been all over the map because there's not a lot to go on. So we don't know if this thing is potentially outside Neosauropoda or if it's within it. If it is it a diplodocoid or a macronarian? These are most of the other sauropods out of the Morrison. The distal caudals don't really tell us a whole lot. There are elements of it that look like could be related to Diplodocus, Barosaurus, but the teeth are not those of a Diplodocus at all. So we can generally rule that out. The other question, is it a basal macronarian, something like Camarasaurus? The metacarpals don't really look like that, but it's still a possibility. Nothing in these elements of the tail, the metacarpals, or the teeth can really rule out it being outside Neosauropoda, so that's still a possibility. So this is basically the main thing that we know. I got gonged. That's like a dinosaurian Chuck Barris there. So we know it's basically not a Diplodocus. That's the main thing. This basically just shows it's from the late Oxfordian, so it's about 4 to 6 million years older than most of the other sauropods out of the Morrison. So it's possible that it's telling us something about sauropods arriving in North America. I will skip over these, and we're going back out again in 2017, hopefully in July. And we'll have a helicopter out there again. Hopefully we'll have more news to report. We found limb material out there on the last day, of course, last year. So hopefully that stuff will tell us more. And I'd like to thank all these folks and you for listening. And I can answer any questions. The question was, what kind of sauropod could it be if it's outside Neosauropoda? Outside Neosauropoda, things haven't really been grouped all that well, so it could be somewhere in a grade close to Jobaria, or I was told at SVP this year that it's not impossible that it could be a Turiasaur, which is a group of non-neosauropods that are known from the late Jurassic of Europe, mainly. So it'll be interesting when we get all this material prepped and be able to do an analysis on this thing, see where it comes out, because it's definitely different from anything else in the Morrison. Yes, the question was if Newberry ever knew that it was not an ichthyosaur. I don't know if he was guessing that first day, or if Dimmick was just guessing and that was some name that was known, but I think Newberry noticed pretty quickly that it was some kind of land animal. He initially told Cope, who described it in 1877, that it was Triassic because it was in some pretty red material. And so Cope described it as being I think a new family of dinosaur from the Triassic. A few years later, it was recognized it was probably actually Jurassic, and that it was a sauropod. So they figured it out fairly quickly. Yeah. Question was the demise of sauropods. There seemed to be some turnovers in the sauropod faunas from one period or epoch to the next, basically. Most of those in the Middle Jurassic Middle Jurassic tends to be dominated a little bit more by non-neosauropods. In a lot of continents, particularly other than Asia, the late Jurassic tends to be a lot of Diplodocus and macronarians. It's somewhat like the Morrison Formation with a few other things thrown in, but Morrison is dominated by neosauropods. That changes a little bit into the Cretaceous when you still have some of those basal macronarians and a random surviving Diplodocus. But by middle to late Cretaceous, titanosaurs pretty much take over and they get very large. They morphologically are very different. And at least in North America, they seem to basically reinvade the continent as far as sauropod fauna goes. So they don't ever completely disappear, except for a short period in North America. And they get big, and they still dominate in some continents, even in the late Cretaceous. But I think there's a fair amount of competition from things like hadrosaurs and ceratopsians that are a little bit more efficient with their oral processing and things like that. So they seem to hang in there pretty well overall. But certainly there are turnovers in who's dominant, which groups are dominant through different periods. Yeah. All right. Thanks.